Hi, everyone, and thanks for joining us today. My name is Matthew Forrest, and I head up our solutions engineering team here at CARTO.
I'm Ernesto Martinez. I work as product manager at CARTO too.
Great, and today we're going to talk about the history and future of Spatial SQL from PostGIS to Spark SQL. So just to briefly go over our agenda for today, we're going to talk about what makes Spatial SQL special, go over a brief history of geospatial operations in SQL, talk about some different use cases beyond just ST-intersects, which is probably one of the most common use cases for Spatial SQL. We'll talk about how we use SQL at CARTO, and then some different things we're working on from GeoParquet, JTS, and the CARTO Analytics Toolbox, and ultimately why we believe the future is so bright in this space. So just like we said, what makes Spatial SQL special? This is a common phrase in geospatial, is spatial is special. And I know it's kind of a lot of alliteration packed together, but just how we define that and how we talk about that. Spatial SQL uses all the same elements and structure of your normal SQL queries, but that allows you to work with another data type, which is either a geometry or a geography. And they're very similar, except that geometry is a projected coordinate system, meaning that's on the Earth projected onto a flat surface of the Earth, or geography, which is the curved surface of the Earth. Now, if you look at that just from a pure perspective, it's just the pure geometries or actually working with that new data type. But we believe that there's a more modern view, which is that Spatial SQL is an interoperable language, and that allows us to work with geospatial analytics, spatial data science, and application development. It provides users with the ability to not only work in the same location as other data or databases or data warehouses, it ultimately removes traditional silos between those geospatial or GIS teams. If you're not familiar with that term GIS, that's Geographic Information Systems, and other areas of an organization. And ultimately, it supports many more advanced operations, things like spatial modeling, machine learning, and it's all in the same location that the data resides in. And what we really believe is that Spatial SQL has become a true analytical tool, not just a database tool. Now, there's a lot of different functions that you can use with Spatial SQL and embed them in modern GIS workflows. Now, the key here is that all of this operations and all the queries are running in the same place that your data resides. Traditionally, you would take that data out of a database and run that in a traditional GIS tool. This allows you to keep that all in one place and make it very scalable. So there's a few different categories here. I'm not going to talk about all these different functions for today, but these are some of the Spatial SQL functions you might come across. Things like geometry management. How do you create these geometries from data that lives in your database or data warehouse? How do you calculate measurements? Things like the area of a polygon or the distance between 2 points or the length of a line. Accessors is actually taking data off of a geometry. Let's say you actually want to get the latitude off of a latitude-longitude coordinate geometry. You can use STX or STY. And then transformations. Can I take something and turn it into a buffer? That allows you to create a geometry from a point that says, now turn this into a polygon that is representative of 500 meters around that specific point. There's also spatial relationships, are probably some of the most common use cases, looking at, do two different geometries from two different tables intersect each other? Do they not touch each other? Are they touching? I mean, that there's a point that overlaps. And then others such as clustering, you can do different clustering cases like dbScan or k-means. Now, this is a really simple example. We're not going to go too deep into this, but this is just a simple way of doing a spatial aggregation, right? So we're going to select from two different tables, polygons and points, represented polygons A, points B, and basically get the sum of the values from our points table that intersect with our geometry. Now, what we can actually do is join that using that function ST-intersects, because it returns a Boolean. So then ST-intersect says, does this return true or false? Yes, we can use the true to do the join there and basically do a very quick aggregation. So an example use case I've seen with this a lot is maybe you have census blocks or block groups in New York City, and you want to join that to get the sum of the total value of all the NYC taxi trips, which is a pretty popular data set in New York City, and the value within each block group. So that's a use case you could use this for. So we'll dive into a brief history of Spatial SQL, how this has been used. Now, Spatial SQL has been around for quite some time. There's been a lot of different versions of this. Some of the early proprietary ones in 1994, it was just Spatial, Oracle Spatial in 1998. And then in 2001, I think this is where things started to really expand. PostGIS is really the first open source toolkit there, which is the extension, or the spatial extension, I should say, of PostgreSQL that allowed more use cases on an open source database system and allowed you to query that. And you can see that these have continued for quite some time, but running these geospatial queries on a database is something that's been in development for quite some time. But these are all these traditional database systems. Now, traditional GIS doesn't work in the way that Spatial SQL or a database system works. So when we think of GIS, like I said, geographic information systems, that work thinks in layers, right? So you have different layers of data. In this case, there's things like land usage or elevation, property parcels, streets, customers. Those are all individual layers that are sort of contained there and layered in and then analyzed separately. Now, what that looks like is these are extrapolated data points from the real world. These are all individual data sets, or basically files that live in a storage system, either locally or a traditional GIS file server or something like that. Now, when we think of a database structure, these can be all individual tables that can be accessed, joined, queried, merged in lots of different ways, and they can all be contained and organized in a database or data warehouse structure, which is just different from how that works. And what you can do is ultimately query those together and do different joins or overlaps and all these different things in the database or data warehouse, and then pull those into the visualization layer. Compared to what you would do in JS, which you take all the layers, visualize them, and then do some analysis from them. So it's a different way than the traditional GIS systems work. Now, a lot has changed here, and I think modern GIS demands these more scalable tools. There's more connectivity. The data needs to be in different locations and accessible to more people. There's a lot more data. It just keeps getting larger. And what that means is two things here, is that there needs to be more processing power because we need to run more complex analysis. And this data, both non-spatial data that can be joined to the geospatial data, but also the spatial data that we're pulling in for these complex use cases, the amount of imagery or remote sensing data that's being pulled in, data from connected devices that's being constantly pushed into data warehouses, or even data like point clouds, which is sort of these 3D layers of imagery or things like that. So there's a lot of just the volume of data is increasing rapidly. So these other tools just can't handle that in terms of scale. And then the demand, we have a lot more demand for shorter question to answer time. People want answers much faster, and there's a demand for that sort of live return of data. And fortunately for us, these databases and data warehouses provide a really good place for us to leverage that, and Spatial SQL is a great tool to do so. So what we come up with, and ultimately what we're trying to solve at CARTO, is how can we leverage the powerful infrastructure of parallel computing for geospatial? And that's a lot of the work that we're doing today. So we'll talk a little bit about some Spatial SQL use cases beyond just the ST-intersects that we showed you earlier. I'll turn it over to Ernesto to talk through a few of these, and we'll take it from there.
Yeah, thank you, Matt. So one of the things that we are, the most powerful things that we are trying to leverage CARTO through the use of Spatial SQL is allowing to reduce your geospatial data to a surface that is easily that we can analyze in an easier way, and there is hierarchical and structured in a way that we can replace the complex computation of the geometry and geography types into very easy mathematical operation that performs very well on the database. So by pushing Spatial SQL that works with spatial indexes to the data warehouse, we are enabling the escalation of the amount of data that we can process with these tools. This is an example. You can see how data is being aggregated as it is requested. In this case, the source of the data is an H3 grid that we are aggregating on the fly through the use of SQL queries that are being pushed down to Databricks in this case. Another use case that we are enabling is the generation of vector tiles dynamically and directly from data in the data warehouse. So if you have a table that contains a geometry column, and this table is too large, so it cannot fit in memory in your browser, and it doesn't perform well, what you need to do is load the data progressively as tiles. And what we are doing here is using a Spatial SQL to generate those tiles and make sure that they can be loaded progressively on client side, and that this performs well in the browser. We're also using a Spatial SQL to enrich your data with data from different providers or data that is ready to be used in your spatial analysis. So if you are a data scientist, you're working with a lot of data from different sources, you will know that this can be a very cumbersome and complicated process that can be eased through the usage of Spatial SQL on some specific data sets that are prepared to be used in this way. Same goes for some very specific functionality as routing through the usage of some stored procedures written and developed in SQL. We can find the closest or the best path between point A and point B using a network where we can trace these routes, and we can also weight some variables. So if we want to obtain the most efficient route or the quickest route or the shortest path, that is something that we can also achieve using the Spatial SQL. In a very similar area, we can also leverage external services from the location data services providers, such as geocoding or isoline generation, reverse geocode, all these kind of services that are very useful in any workflow when working with your spatial data. This is our approach here is to develop procedures that they leverage functionality from external providers. So we are able to geocode a whole table that contains only zip addresses, for example, and convert that into a table that contains points for these locations. And another very interesting use case and very powerful is the creation of advanced spatial statistics functions. So in order to get like advanced spatial data science workflows, we are developing functions that enable these use cases, and that push the computation, the heavy lifting of the data is pushed to the data warehouse, where we can profit from parallelization and the escalation that is already available in Databricks, for example. And based on all the previous things, we take those foundations to build vertical specific functions that will help solve problems for specific industries. For example, retail or out-of-home advertising. We will take all the pieces that were described before, and with those building blocks, we can create new functions that are industry specific.
Cool. And I think the one really important point to call out is that Spatial SQL is now well beyond just the ability to query data, look at interactions. It's becoming a true support system for all these analytical processes, and even beyond analytical processes, for everything from visualization to how do we look at things in questions of adding data like geocoding or enrichment, which is a really tricky problem if you think of it from a geospatial perspective. How do I answer questions from multiple disparate data sets from the census or human mobility data or anything like that? Adding spatial statistical functions, and then I think ultimately packaging those up in different ways to make them specific for specific verticals. All of that supported on a really scalable system like Databricks that can help you scale and use that parallel processing to your advantage to really massively scale your analytics using all that large scale data that we are collecting that we talked about earlier. So awesome. Thank you, Ernesto. That was awesome.
Thank you, Matt.
So I'll turn it back to you to kind of talk through some of how we're using this at CARTO today, and we can talk through some of these cases too.
Yeah, we have a few examples of different ways we are leveraging the power of Spatial SQL for analysis. This is related to the last thing I was mentioning before. We are able to, taking the GeoSpatial foundation building blocks, let's say, we are creating domain-specific modules on each on the Analytics Toolbox, which is the kind of the extension that we distribute for the data warehouse. This is an example of the UI we have in our product that allows creating chained SQL analysis queries that allows you to perform the most usual GIS workflows. So in the example, you'll see that we are computing the centroids from several points and aggregating some data, and that UI will create a SQL query that we can just run. This will be loaded as a layer in the map, and as mentioned before, all the heavy lifting of the data will be pushed down to the data warehouse. Vector tiles are like the base of the technology we are building. All of our maps use vector tiles, and getting vector tiles from a huge table that you have on a data warehouse is not easy at all. It's a very tricky procedure because some very specific low-level details that when you are dealing with the spatial data, and you need to break it down into smaller pieces to be served at scale. But luckily, using SQL and the native geospatial, the support for geospatial types on the data warehouse, we've been able to figure out the most optimal SQL queries that allow us to get vector types directly from the data, from a table or even from a specific SQL query. This is an example of a big volume of data. In this case, are the block groups for the whole USA. And as you can see, as you move around the map, you zoom in and out, the data is being loaded progressively. Each of those tiles that are coming to the map are being calculated in the data warehouse.
Yeah. And in a traditional kind of geospatial workflow, you'd have to pre-generate these tiles, and then they are effectively static, right? With the data warehouse, you can use that processing power to regenerate them and update them with some of the freshest data. And that's all within a SQL query. If I want to do an aggregation or anything to millions, billions, trillions of points that lie underneath this, that's totally on the table and quite easy to do.
Yeah. Thank you, Matt, for the clarification. Also, coming back to something we mentioned before, we are now leveraging SQL to support the usage of spatial indexes with discrete global grid systems. We are going to enable support for H3, leveraging the native set of functions that are going to be available in Databricks soon. But we're also supporting other spatial indexes, discrete global grid systems like PostGIS or S2. This is an example that is displaying the hexagon tiles that we use to load the data coming from H3. And as I was mentioning before, this is also aggregating data on the fly when it is requested in the map. So as you zoom in, you will see that the data is being shown in a more granular with a higher resolution. And as you zoom out, you'll see how it aggregates into bigger hexagons to be rendered in the map.
So in the next section, we're going to talk a little bit about some of the other interesting things we're working on: GeoParquet, JTS, and the CARTO Analytics Toolbox. So I can kind of jump in on GeoParquet. I think this is one of the most interesting things that we're working on. And Ernesto, I'd like your take as well. But geospatial data, if you ever worked with it, comes in lots of formats. And when I talk about formats, file formats. There's libraries built just to handle that. There's hundreds of different file formats, literally. Additionally, there's no interoperable single format that works across the data warehouses. GeoParquet looks to solve that using, if you can tell by the name, the Parquet file format base to bring that in to the geospatial world. That allows us to load these files, go across all the different data warehouses, but also gains a lot of toolkits for anyone that's even loading these data locally and gets the same scale and performance gains out of Parquet. But it's complete interoperability across all the data warehouses, which I think is one of the most interesting things we're working on with lots of different companies and providers too. So.
Yeah, totally. Our bet is that Spatial SQL is the future of the spatial analysis, and by enabling interoperability between cloud data warehouses, which use SQL to leverage all the computation capacity, what we want to do is to make this easier and more performant by enabling interoperability between these cloud data warehouses. This is another short video showing a very simple spatial intersection that leverages the Java topology suite functions through Spark SQL. This is a package that can be installed in your Databricks cluster that enable a set of functions that can be used directly from Builder or also from CARTO Builder or also directly in your SQL notebooks within Databricks. So they enable the very basic GIS tools as the intersect. You can also compute geometry intersections. You can calculate centroids. You can run all the basic GIS operations using SQL in your Databricks notebooks or in your CARTO Builder Builder account. And then on top of these basic functionalities that I was mentioning before, the plan is to build some more advanced modules, like the ability to create static tile sets that Matt was mentioning before for these occasions when the data is like really, really large and it's more performant to have them pre-calculated, but also some other very specific functions that we were also mentioning before, like geocoding, routing, etc. Those will be part of an advanced module that is built on top of the from the basic functionality that you see at the bottom of this graphic. And on top of the advanced is when the domain specific and the verticalized functions for specific industries will appear.
All right. And the last point we want to make is I think the future is very bright. Traditionally, you wouldn't think of databases as the backbone of spatial analytics. They're simply a place to store data, maybe do some light transformations and querying. But more and more, as data warehouses, tools like Databricks have expanded and allowed for these really large, scalable use cases. And as geospatial data has grown significantly, we've seen that the need for this use of parallel processing and getting closer to running the analytics closer to where the data is has become very, very necessary. Now, extending that within the geospatial world, some of the traditional problems of visualization, data enrichment, spatial statistics and modeling, things like location data services, geocoding, routing, all problems that have been done outside of the data warehouse or the database can now come into that same world and take advantage of all the performance boosts that we're seeing there. So I think there's a lot of options. And I think the most important one is that geospatial work, or GIS, has been traditionally siloed away from these tools and systems that other teams are using, whether those be data science teams, analytics teams, data engineering teams. They've been separate, and now those worlds are coming together. And I think there's a massive opportunity for cross collaboration and using geospatial data together to create more advanced analytics and ultimately solve really interesting problems, things like climate change, CPG and inefficiency, logistics, routing, retail problems are all ultimately dependent on geospatial data. So the more we can enable that cross collaboration of teams working together, I think that we're going to see that happen more and more. And I think we're going to see that happen more and more in data warehouses and in tools with Spatial SQL. So from our perspective, the future is very bright here. And we just want to say thank you for attending today. If you have any questions, you can reach out to both of us at any time. We're both on LinkedIn, or you can touch base over email. But we appreciate it, and thank you so much.
Thank you very much.